All right, so polyatomic ions really are no different than any other ionic compound, other than the fact that we now have a whole bunch more that we got to kind of just go through and get used to looking for. So I'm going to give a couple examples, one kind of going from name to formula, and the other going from formula to name. These can be a little bit more along the simple kind of ionic compounds, where we have a polyatomic ion together with a metal that can only have one potential ion charge, or it could be something where we need Roman numerals in there as well. All right, so let's go with one of the ones that probably would look the strangest. All right, and so I'm going to start with, I'll write the name out here. And we'll make it a little bit on the complicated side. Chromium 3 dichromate. So this is probably as hard as I could make a question for you, really, because you look at this and you go, chromium dichromate, what in the world's going on? But then you go, oh yes, dichromate, that sounds like a polyatomic ion. My first step is I'm going to write that down. I got to find that polyatomic ion thing first. And I find, oh, dichromate, there it is, Cr2O7, and it's got a 2- charge. So what that tells me is I've got these 2 chromiums with 7 oxygens, and between the 9 atoms there that are all bonded together, I have 2 extra electrons, and so I've got a -2 charge. Chromium 3, that tells me it's chromium with a 3+ charge. All right. Now at this point, it's just a matter of going, okay, what do we got going on here? Well, I have 3 pluses, I have 2 minuses. Okay, I need to have 6 pluses and 6 minuses so that this will balance. So I need 2 of these guys. And I'm going to need 3 of these guys. I'm going to notice that this gets old writing this out pretty quickly. So at some point, you're probably going to want to just switch to saying ×3 next to it or something like that. Either one works, but now I'm going to have Cr2. This is going to look really stupid. Bracket Cr2O7, closing bracket, 3 times. All right, so Cr2O7, 3. And no, you cannot make this Cr4O7 or something like that. This dichromate thing, this bit here, this is the negatively charged ion. This bit over here is the positively charged part. All right, so like I say, that's as hard as this is going to get in terms of just looking weird and confusing. All right, let's take a look at another one that's a little bit nicer. What if I have, and I'll just type this one in because that's quicker, sodium acetate. Make it slightly bigger, maybe. There we go, lovely. All right, so at this point in time, I go and find sodium on my periodic table, and I say, oh, good. It can only be Na+. Hooray, I don't have to worry about Roman numerals. Then I look on my list of polyatomic ions, and I go, acetate, where is that? Oh, there it is, right near the beginning. CH3, COO-. This one's really nice because there's 1 plus and 1 minus, and my formula now is just NaCH3 COO. Looks like some weird misspelling of the word nacho. Anyways, moving along, let's start with the formula now. And this is where the hard thing isn't actually doing the work. The hard thing is recognizing the formula for what it is. So let's look at one of the only polyatomic ions that has a positive charge, and that's ammonium. So I'm going to look at NH4, and we're going to go with F. So I look at this and I go, NH4, what in the world is going on? NH4F. This looks like just a random string of nonmetals, but then I go, oh wait, NH4 plus, that's ammonium. F minus, that's fluoride, right? So looking at breaking it down into its ions, this will be NH4 plus and F minus, and I just name each of the ions. And so this ion here, this is ammonium. And then fluoride, which I spell correctly by putting the U first. All right, let's go with one more here. That's a little bit more, maybe a little bit more tricky. Let's look at Fe3 PO4 2 times. So I've got an iron, that's my Fe, and I find PO4, and I look and say, oh, that's phosphate, not phosphide. Now I got to look and say, okay, well, phosphate is PO4 3 minus, and I have 2 of those. And then I look at Fe, well, it's going to be 2 plus or 3 plus. Now, I've got 3 of them, so 3 times 2 is 6. So this is the 2 plus version of iron. This is Fe 2 plus. And here we go. This is going to be iron Roman numeral 2. Phosphate. How did I get there? Again, all I did is I looked at my polyatomic ion. Ooh. I'm going to learn how to spell too. That'll be great. Phos. Oh, that was supposed to be an H that I just totally messed up. Try again. There we go. Got it. Here we go.